All right, let's do it. So this batch X and this batch Y, it's just the raw image path and the raw bounding boxes, which have like the comma delimiters in here. So we need to remove that and make it an official input for our model. Okay. So let's try to make the class. Give me a second. All right. So after get the item, we gonna create an empty official image for that and train label equal empty array. Now we loop over the batch size, image path, label equal label. So we read them. All right, and return train image and train label. Okay, so this is something we have implemented. So this can return the actual image array with the size of image size, and by 3. This is the RGB, and the label gonna be in the size of grid size, and grid size. Oh no, and 5 times box size plus class. So each box we're gonna have. Yeah, I'm gonna explain it later. When we do this read function, self image path and label. Okay. Alright, so first we're gonna read the image equals CV image path. Okay, and the height and the width of the image gonna be equal to image shape 0 to 2. Image equal to CV dot resize image size and image size. Okay, so we're gonna resize it into our image size, and before that we're gonna store our height and width so that we're gonna converting the x, y into the value of 0 and 1. First, we're gonna try to standardize them first. Oh my god. Okay. Oh. Okay. So we make the empty label matrix equal np0s with the shape of grid size. Actually, I can copy this. Cool. Oh, no class. Great. So for L in label, L equal L split, delimiters equal the comma, L equal numpy array, L. And the type one is int. Okay. So x min, y min, x max, y max equal L 0 divided by the width. Y min gonna be equal to L1 divided by the height, L2 divided by the width, and L3 divided by the height. So we all want to make it into the value of from 0 to 1. Okay. And now the actual x is the midpoint. Okay. So we sum x min plus x max divided by 2, and y min plus y max divided by 2. So the actual width and the height is going to be x max minus x min, y max minus y min. Great. Y, and so now we're going to try to convert x and y relative to the cell. Okay. So I and j equal to int grid size times y and int grid size times x. And the actual x is going to be grid size times x divided minus j, and y equal grid size times y minus I. So the reason for this is like, for example, if we got grid size is 7, and then 7 times something 0 to 1, we're gonna make it from 0 to 7. Okay. So for example, we have 6.43, and minus the int version of them, 6.43, we're gonna get 0.43. So relative to the cell. Cool. All right. Hope you guys understand that. And then we're gonna do the label. Okay. If L4 equals 0, which is a dark, then the label matrix is gonna be at ij gonna be x, y, w, h, 1 because it contains an object, and then 1 and 0. So this means 0, and this means 1. Okay. And then we do the same thing. Ouch. 1, and now it's 0 and 1. So it's like a one-hot encoding. So for example, if we would have like one more classes and it's encoded as 2, then it's gonna be like this. Yeah, just my convention. You guys feel free to change the order, but yeah, it's gonna be that for now. Alright, now we're gonna return the image and the label matrix. Okay. Alright, let's see. Oh, it's okay. Yeah. So let's see. Oh, remember, this is tf.keras, okay? tf.keras, not keras, that uses sequences. Now let's try to testing that. After we have creating that, we have already changed it into a separate x and y, and now we're gonna make it an official data. Okay. So training data generator equal to data generator x train and y train. Okay. Copy that. Do the same thing for validation. All right. And training. Oh yeah. Okay. Okay. Now let's see if we can try to extract one item. Data generator get item. Let's get the first item. Okay. So this is the reason why I have index in here. And let's see the size of that. Come on. Oh, it's not working. Okay, wait. Oh, it's I, it's not J. Yeah, it's I here. Alright, it's working. So let me show you the shape of them. This is a shape. Wait, no. Training data generator, get. Oh, yeah, we need to change it into a NumPy, okay? So let's do NumPy array. And the type gonna be float32. The type equal float32. np.float32. Cool. Same thing with this one, np.array. Float type np.float32, okay? Alright. List of what? Extreme thing, get item. Return. Oh, my bad. I should do the opposite image label matrix. We should actually make it an NumPy array over here. It's gonna be the train image and the train label. Great. So you see, it's 128. That's why I say. So the reason why, yeah. So instead of loading 1,500 images, now we only need load 1 batches and input it into the model whenever we fit that. So that's why it's really save the memory for our CPU, like our machine, and we only mainly use the GPU. Okay. All right. Now let's try to view that. So let's make a function. Def test print. We're gonna input the image and the label. Okay. So for I in range of the grid size, and for j in range of the grid size. So if the label ij 4 equal 1, then we print the label out xywh equal to label ij in the first 4, xmax equal. Oh, now we're gonna try to do the reverse math of this whole calculations. Okay, so int x plus j divided by grid size times image size, and now we plus the width times image size and divided by 2. That's the xmax. And 4 of them is gonna be xmin. This is the ymax and 1. I is for the y and j is for x, so that's why we do this. And for xmax we're using plus, but for min we do minus. Okay. Cool. The class name equal the class array, and we're taking the maximum argument label ij of the 2 value, okay, at the last dimension. The class array is over here. Oh, I agree. So yeah, I make the class array previously. Let me try that again. So the class array equal this one equal to the list. So we change the class system into a list. Okay, let's try that. Print class array. Cool. Yeah. All right. Yep. Almost done. So now cv put text. We put text into the image. Have the class name, the text, and the origin gonna be xmin ymax plus 10. Okay. So we're gonna input the text down after the bounding box. So fun. We have this complex. Let's do complex small. And the scale is 0.5. The color gonna be 225 to 55. Then I do cv put rectangle. Image origin gonna be xmin ymin xmax ymax. 55 to 55 to 55. And thickness gonna be 1. Okay. And then pld and show image. Right. So the reason why I'm not using cvm show is that it might crash our Jupyter notebook. So I'm just gonna use matplotlib. Where matplotlib.python-plt. Cool. Okay, let's see if it's working. Great. Test print. So our image is the x train 0 and the y train 0. Whoop, working. And you see a dock over there, and it's not that big, so yeah, just do a normal one. Oh, actually, I think that just increase the scale. Have the clock go over there. That's great. Index equals 0. Move everything into index. Let's try another one. 3. Okay. Oh, so it's in the BGR order when we do CV imred over here. So we might want to change the order. I mean, the order is not really important, but in case we want to make it more easier to see, then yeah, let's change that. CV image. No, BGR color. Yeah. Oh, convert color. No, color BGR to RGB. Yeah, that's what I want. Yep. Now we can see that. A dog, a cat, 6. A dog. Cool. All right. So that's the second part. Now we're gonna go to create a model and start training. Okay.